So good evening, everybody, and firstly, welcome to this CII Energy Efficiency Leadership Series. As many of you may be aware, this is the 8th edition of the Thought Leadership program that we have launched. And it's indeed a proud privilege and honor for me to welcome and have today one of our tallest leaders in the Indian industry, and also one of the leaders in the area of energy efficiency. We have with us Dr. Naushad Forbes. I think not, he probably doesn't need an introduction, but I think we just need to give for those people who are on the CII Hive platform. I will try and give a quick, short introduction to Dr. Forbes. I think Dr. Forbes is the co-chairman of Forbes Marshall and also past president, Confederation of Indian Industry. Under his leadership, Forbes Marshall has transformed into a leading steam engineering and control instrumentation firm. He's also, brought in a lot of new initiatives encompassing energy efficiency, capacity building, training and skilling, and also the industry-academia relationship, which of course is extremely important in the context of science and technology area. And of course, he's one who has been advocating innovation as a key pillar for the Indian industry as well. Dr. Forbes also leads and as a chairman for the Ananta Aspen Center, the Bharatiya Yuva Shakti Trust, and the Center for Technology, Innovation and Economic Research. Dr. Forbes, he has completed his bachelor's, master's, PhD from Stanford University, and was also a consulting professor at Stanford during the period 1987 to 2004. Dr. Forbes' leadership contribution is quite very intense, and it take a long time for me to go through. But on a very high level, I think he's been leading and mentoring us at CII as a past president of CII, co-chairman of the Economic Affairs Council, and chairman for India at 75 Foundation. Dr. Forbes also has been instrumental in developing many educational and capacity development programs on technology. He's also a board member of several educational institutions and public companies, chairperson, National Committee for Higher Education, Innovation, Technology, and International Business, and a strong advocate on the importance of energy efficiency for achieving competitiveness in the Indian industry. I think there's no better person to talk about energy efficiency, and we are extremely honored to have you, Dr. Forbes, this afternoon, and we really look forward to hearing from you. With that brief introduction, I would hand it back to you, Dr. Forbes.
Thank you very much, Ravi. Thank you for your very warm and kind introduction. And it truly wasn't necessary for a couple of reasons. First, this is a CI audience. Second, this is a CI GBC audience, and it's always a great pleasure to participate in any function of the Green Business Center. As I think many of you would know, the Godrej GBC is one of our most, in fact, not one of our most, it is our most successful center of excellence within CI. It provides a range of services that are hugely appreciated by industry. And I think many of the programs that we run from GBC are really landmark programs that have pioneered and initiated a whole series of things for Indian industry and for India in general. The Green Building Program is our flagship program. And I think India today, Giri, am I right in saying that it has, today we have the second largest number of platinum rated buildings in the world. And I think I'm right in saying that out of all the Green Building Code rated buildings in the country, GBC, Godrej GBC, has actually assessed about 80% of them. Would that be right? Yeah, I think those are the numbers I hear from time to time. So we've truly I think pioneered the entire field for the country, and it's a wonderful contribution. So I want to thank you both, Ravi and Giri, for the opportunity to think about energy conservation and to think about energy scenarios at present. Over this is sort of our business as a company. It's been a long-standing passion for me, but in recent years, I've kind of gone off into too many directions and too many general things. So this was a nice opportunity to revisit the entire energy field, to catch up with what's been happening, because I've been reading the papers and reading articles here and there, but I've not thought about this systematically in some time. And what I did was to, as a part of preparing for today, I looked at 2 books, and I wanted to mention them and recommend them. One is by a Nobel Prize-winning physicist named Burton Richter, who wrote a book a few years ago called Beyond Smoke and Mirrors, which is a book about climate change and energy. In fact, the subheading is Climate Change and Energy in the 21st Century. The second is a book called Fossil Free, which came out just a few weeks ago by Sumant Sinha. Sumant is one of our leading CII members. He's a past chair of the Northern region. And again, both are excellent books, I think, in terms of providing background in the broader space of energy, climate change, and a certain amount on energy efficiency. So what I'm going to try and do is to talk about 3 different topics, and I'm going to talk about these topics as a base for us having a good discussion and good Q&A session afterwards. And I'll try to be as brief as I can so that we have more time for Q&A. And the 3 topics that I'll briefly cover are to give you some background on the energy scenario in the world today and in India today. And my purpose is not to be comprehensive, is just to provide you with enough background so that we're all starting from the same point. It's not, I think for this audience, it won't really be adding a lot of knowledge, but I think it's important for us all to be at a certain common platform. Second, I'll talk particularly about the potential for energy conservation within our energy scenarios, within the future that we are trying to build for ourselves in a more energy efficient and climate friendly world. And then third, I'd like to spend time talking about the economics of energy conservation and climate change, because it seems to me that I'm going to make the case anyway, that unless we address the economics, we keep sort of going 2 steps forward, 1 step back in our efforts to improve our energy future. So let me start with some background on the energy scenario in the world and in the country today. And this is just, let me start by reminding you that we are currently, as a world, going through a great energy transition. And the world has been through 2 energy transitions in the past. The first was a few years ago. The first was started in the late 18th century with the move from human power, animal power, and wood as sources of energy and as motive forces. And it was a move to the use of coal and the steam engine as a way of powering what we wanted to achieve as humans. So that really powered the steam engine, and coal powered the Industrial Revolution, and it set in place the 200 years of economic growth that we've seen over these last 2.5 centuries. The second energy transition, as you all know, was the transition to oil, which started in the late 19th century, but really picked up speed post 1950. And probably its leading feature has been the transport revolution, that the availability of a cheap, highly energy compact fuel provided. It's powered air travel, road travel, shipping. The cost of shipping today, if you look at the cost of shipping today, I believe the number is 2% of what it was 150 years ago. And that kind of dramatic change that's taken place is thanks to the second energy transition, and it's thanks to that kind of dramatic change in the cost of moving goods around that we have the world that is as integrated as it is today. And now we're in the middle of the third transition, with renewables joining the mix, and with renewables growing hugely in their share of new energy capacity being put in place in the world. So if you look at where the world is now, the rough numbers at present for the world says that the world relies today roughly 27% on coal, about 23% on natural gas, around a third, 33% on oil, around 4% on nuclear, and renewables are around 11%. Yeah? And if you add the numbers up, that says that the world today is reliant on fossil fuels for 85% roughly of its total primary energy needs. If you look at the use of where energy is used, around a third of total energy is used worldwide in industry. Around 27% is used in transport, 29% in buildings for heating and cooling, and around 11%, the balance is for everything else. So if you look at India and the Indian scenario relative to the world, you'll see that coal plays a much bigger part in our totally primary energy sources. Coal is over 50% of India's total energy sources. If you take formal energy sources, I'm not counting energy sources that come from animal waste, which is still a significant share of our total primary energy demand in the country, but it's actually something we need to move away from. Natural gas is very small in India, growing but very small. Oil is significant. It's also around a third, as it is worldwide, of our primary energy sources. Nuclear, a little smaller than worldwide, so instead of 4%, I think we're at around 2-3%. And renewables, against the world's 11%, we're at around 9% in terms of total primary energy sources. But if you look at renewables in our own country today, renewables are growing massively. Recent bids for solar power, utility-based solar power, have come in at the lowest rates in the world, at roughly 2 rupees 35 paisa a unit. That compares with, if you look at the numbers, that compares with a cost of 3 rupees and 20 paisa per unit that NTPC charges for its own power when it supplies it into the grid. So new solar power is today significantly cheaper than existing, let alone new, than existing thermal power based on coal. And as a result, in 2019, last year, we added totally as a country around 20 gigawatts of electric generating capacity, and 60% of that 20 gigawatts came from renewables, roughly 9 gigawatts from solar and 3 gigawatts from wind. So we've seen this huge shift that's taking place in a very short period of time, in basically the last 5 or 6 years, from being almost entirely reliant on coal-based electric power to being much more now investing in renewables. And this is, we're living this third great energy transition in our country as we speak. Our goal as a country, as you know, is to raise the current percentage of renewables in our energy mix from 9% to 25% by 2030. That's what we've committed. And it's a very challenging goal, but a goal that is actually achievable on the basis of the current generating capacity and tenders and so on that are being issued. We've also made a commitment as part of the Paris Accord that by 2030, we will reduce our energy intensity per unit of GDP by around 35%. That's from 2005 to 2030. And that 35% reduction is actually not difficult to do. We're actually, as of now, as of 2020, we're actually ahead of where we've committed to be if you draw a straight line between where we were and where we have targeted being by 2030. And we can aim to do better. And all of this says that, you know, for many, many years, for decades, I mean, when I was in college in the late 70s and early 80s, you know, solar energy was always spoken about as of the future. You know, solar energy is coming and it's going to be of the future. And I started getting worried that at some point in time, you know, solar energy always seemed to be in the future. It was like Brazil. It was of the future, and it always would be of the future. But in the last 5 years, it's become very much a reality. It's become something that is very much a source, an energy source that's available to us here and now, and that's taking an increasing share in our total current energy scenario. Let me move to the next topic, which is energy conservation. In all of our talk about this energy transition and new energy scenarios, you know, I feel that energy conservation doesn't get as much attention and as much focus as it could very usefully get. And let me give you a few numbers to help make that case. A recent article in the Financial Times about a month ago, I think, reported a study that was done in the US recently. And it made the comment, it's quite an astounding comment. It said that 67% of primary energy in the US is wasted, right? And that just 33%, 1/3 of all primary energy in the US does useful work. And that's a fairly dramatic statistic, if you think of it, that 2/3 is wasted, 1/3 does useful work. Yeah. So that's the potential. It's not that the technology exists here and now for us to be able to achieve that, but in terms of long run development, that's the potential, right? Where does this 33% useful work come from? Well, the average thermal efficiency of a coal-fired power plant in the US is currently 32%. It's not very different in our own country. It's also, I think, around that same figure. Giri probably can give us a more accurate number. I think it's around 30% in India now. If you take the average efficiency in transport The average efficiency in transport in the US is 21%. If you take average car efficiency, which is about 2/3 of all the consumption in the US, it's much less in India, by the way. If you take average car efficiency, around the car efficiency, actual car efficiency is typically around 12%, right? What happens to the remaining 88%? Well, 60% is lost to heat, right? Nothing else, just to heat. 17% is lost in idling, meaning the car's not moving at all. And then you only have around 18% of all the energy that actually starts to go to the drivetrain. And by the time it actually reaches the wheels and pushes the car forward, you end up with only 12%. So you've got these huge opportunities for energy saving that happens right across the chain. If you compare an electric car converts around 90% of the energy that's stored in the car into useful energy that moves the wheels. Because of direct drives, you don't have a transmission, you don't have all of these various mechanisms that are inefficient in transmitting energy from one source to the other. And as long as that electricity, that's a big if, as long as that electricity doesn't come from coal-fired power plants, you're okay. But if the energy comes from coal-fired power plants, then you're starting off with 32% average efficiency, and then going from 32% down by another 10%. So you end up with a lower efficiency, but still a lot better than in a regular internal combustion engine, petrol-driven car. A second study, again reported in the Financial Times recently, was from Cambridge University in the UK. And it made the comment on energy efficiency that using only existing technology, so this was their qualification, using only existing technology, consumption could be reduced, energy consumption could be reduced by over 20% without difficulty. And that means that if you take, say, 80% of our energy needs being met by fossil fuels in the world today, right, a 20% decrease means that we can see a 16% fall in greenhouse gas emissions or in carbon emissions simply by energy efficiency using current existing technology, right? And a 16% fall in total emissions from the current base is a very substantial number. It creates a lot of space for us to meet the world's and India's long-term greenhouse gas emission targets, global warming targets, and so on. How does this? So what are the things that we need to do? Well, let me give you a couple more numbers in terms of the potential for energy conservation. One more number from Burton Richter writing about the US. He points out that after the oil shock of 1973, when the price of oil multiplied overnight almost, the US put in place compulsory fuel efficiency standards for automobiles. These standards came into effect from 1975. And he shows that in 10 years, from 1975 to 1985, the average fuel efficiency in the US rose from 14 miles per gallon to 28 miles per gallon. In other words, average fuel efficiency doubled in a 10-year period. That's quite, if you think of it, that's quite a dramatic improvement that took place in a pretty short period of time, right? If you look at the energy intensity to GDP metrics for the world, energy intensity to GDP has been improving. If you go back a long time, if you go back to 1900, from essentially 1900 to 1970, energy intensity to GDP improved by around 1% a year, right? So the world was getting roughly 1% more efficient each year than it was the previous year. between 1970 and 1990, energy efficiency improved by 2.7% each year. Since 1990, it's gone back to about a 1% improvement rate year on year. Now I'll come back to why we saw this dramatic improvement from 1970, and then we've seen it level off after that. Let me give you an example from our own company. We work in thermal energy conservation in industry, and in 2003, we did a study together with CII to estimate the difference between the average efficiency of a plant in its use of steam energy and the best in that industry. And we found that the gap between the average plant and the best plant across, if I remember correctly, 6 industry sectors was 21%. We then did another round of the study in 2009. And in that 6-year period, there was an improvement of around 20% in the efficiency with which energy was consumed in industry. And we found in 2009 that there was still 21% potential and gap between the average plant and the best plant. So the average had improved by 20%, but the potential was still another 20%. And we're now in the process of doing a third round of that study. Again, we would expect to find that average efficiency has improved by a further 20-30%, but we would guess that the potential, if we go by the energy audits that we do typically and so on, we would guess that the typical potential for energy efficiency and energy improvement actually is between 18 to 20% even now. So there's still this continuous ongoing opportunity that exists for energy conservation across industry. Yeah. And in India, industry consumes around half of all the primary energy in the country. So if we can improve energy efficiency in industry, we're really going to dramatically improve the energy outlook for us as a country. Let me give you another example from our own industry and our own field. One of the things that we've been focusing on of late is something very simple. It's called condensate recovery. I'll explain it in a sentence. When steam is used as a source of process heat in industry, the steam condenses. You use the latent heat in the steam to heat your process, and then you're left with condensate. Now, this condensate is valuable. It contains heat. It's typically at 100 degrees or so Celsius, and it's very pure water. Now, you would think that it's fairly obvious that this valuable condensate should be returned back to the boiler so that you capture the heat that's in the condensate and you use the clean, pure water that condensate is. We've done a mapping exercise for industry just these last 2 months or so, and we find that there is roughly potential to improve condensate recovery by around 30%. What does that mean? It means a saving in fuel cost, so fuel reduction in actual fuel consumption of around 7%. And that adds up to about 1,000 crores a year for the plants that we currently map this for. And the water saving that we're talking about comes to around 3,500 tons of water per hour, right? So a very significant number again. If you want to convert 3,500 tons of water into something that we can relate to, 3,500 tons of water is about 300 tankers. So it's about 300 tankers of water saving per hour, right? Now, as you all know, as a country, a water scarce country, and here we have already easy potential, attractive payback opportunity to save 300 tankers worth of water an hour. So that's the potential that exists in energy conservation. I mean, this is one specific example. I gave you the US numbers for cars and so on. But if you look in almost any area, you will find similar potential savings. You know, any of you who you know, in the last 8 months, we've got used to not being in hotel rooms for conferences like this one. But typically, if we were in a hotel room, we would be fiddling with the thermostat because it's generally either too cold or too hot. And for some reason, you know, and this is an opportunity for Ravi, for your business, you know, that you know, generally, I mean, I can never understand why our hotel industry cannot get the temperature in public space broadly right. It's literally either the air conditioning either seems to be off or it seems to be on absolutely full blast so that everyone freezes. So lots of opportunities to potentially save substantially in our energy consumption. Let me come to the last topic, and then I'll stop, which is the economics of energy conservation and climate change. Because I think that unless we address the basic economics of energy conservation and climate change, we're missing a huge opportunity. You know, I started talking about us being in third great energy transition to renewables in place of fossil fuel. If you look at the US used to be like India, around 50% of its total primary energy came from coal. This was not that long ago, this was 20 years ago. And then thanks to shale oil and gas, coal dropped to around 20% this year in terms of its total primary energy usage, energy sources. But next year, coal is projected to rise. Coal use in the US is projected to rise by 23%, replacing that extra increase in the total share coming from coal is going to again take the place of gas. Why? Because this year, as a result of COVID, energy prices fell. Because energy prices fell, drilling was cut back in the US. Because drilling was cut back in the US, gas availability dropped. Because gas availability dropped, gas prices went up. And now coal prices are lower than gas prices. So next year, coal is going to show its first substantial growth in consumption in the US in 20 years. Yeah. Now, renewables will still grow a little bit, but emissions in the US are going to rise next year because of this switch from gas to coal. Now, as a company, let me give you another example. As a company, we're now quite active in different parts of the world. And as we've gone around and tried to promote energy conservation in different parts of the world, there is some place, you know, in India, we get a very warm reception when you go and talk to any company. You go to Indonesia, you get a warm reception. You go to most countries, you get a warm reception, but there are some exceptions, right? In Bangladesh, for example, Bangladesh has long had highly subsidized fuel. They have a lot of gas. Gas is provided to industry at a subsidized rate. And until recently, it was provided in a very strange way, which is that they had meters, gas meters, on the boilers that were operating, but they didn't trust the meters. So because they didn't trust the meters, they said, okay, you've got a 5 ton per hour boiler, so this is your monthly charge. So it was based on the boiler capacity, not based on how much gas you consumed. Now, if you operate on that basis, you remove any incentive to actually save energy, because why should you? Yeah? That started to change now in the last 2 or 3 years. And there's a real push now in Bangladesh, with a lot of opposition, by the way, from industry, to meter gas and to charge for what is actually consumed, which is the base of energy conservation efforts. In Egypt, gas and oil was heavily subsidized. And over the last 2 years, again, there's been a move to remove those subsidies. And as you remove those subsidies, again, the interest in energy conservation is growing. I think in India, we have long had much better economics. Fuel costs have been relatively high. We've tended not to subsidize, especially not subsidize industry in terms of its energy. So we have better practices that have been in place for a fair amount of time. But even in industry, in this last 8-9 months, as oil prices have fallen, what have we seen? We've seen that a previous shift that was taking place to biomass as a fuel source for generating processed steam has slowed down. And people are going back to using their old oil-fired boilers. I'm sure that will correct itself. But a lot of this is short run on the basis of actual fuel costs. So what should we do? And this is what I'd like to end with. And I'd like to end with a proposal. And this is a proposal that that Giri has, I think, heard before. So I'm going to make the proposal that high energy prices are good energy prices, because high energy prices force conservation, force a reduction in emissions, and force one to do all those right things that will push the world in the right direction. And not only are high energy prices good, but an energy price shock is even better, because an energy price shock really captures everyone's attention. Remember that bit from the world's 1% reduction from 1900 to 1970, and then jumping to 2.7% over the next 16, 17 years, until oil prices fell again, right? So an energy price shock is even better. So here's my proposal. So my proposal is that we should tax ourselves at a rate of 100% for all our energy spending. So whatever we pay for petrol or diesel for our cars, electricity at our homes, or fuel oil or coal or biomass in our plants, right? Whatever we pay, we should write the same check to our own account, right? I'm not suggesting that we be generous and pay the tax to the government. I'm suggesting that we just take whatever we're spending and put the same amount again into our own account, and then use that money for anything that we wish, to invest in anything that we wish. We can use it for a company party if you want. Use it for anything that you wish. Use some of it, hopefully, for energy conversion matters, energy saving matters, pollution control matters. I hope we will use it for that. But it becomes then a resource that's available. But the key thing is the high energy cost. Because if we have a really high energy cost, and if our energy costs double from next month, right? So do it from the 1st of January. If our energy costs double from the 1st of January, the shock that we would receive would focus our minds and our attention on all those different things that will then drive a really good energy saving program and a climate change program. Yeah? Let me stop there.
Thank you, sir. Thank you for that brilliant lecture. Delegates, may I request all of you to kindly send in your questions through the chat box. We will communicate the questions to Dr. Forbes. We have already received quite a few, sir. I'll present them one by one to you for your opinion. The first question, you spoke about energy transitions. A few of them have asked, what do you think is going to be the next energy transition? Is it a fossil-free energy, or automation, or transportation? You're muted, sir.
sorry, sorry about that. So I said the energy transition that people are talking about now, that we're in now as a third great energy transition, is a transition from fossil fuels to renewables. Now, what do we include in renewables? We certainly include solar, wind. Some people include hydro and should. So we include a set of things in renewables, geothermal, and people very often also include biomass, right? And let me give you good biomass example, bad biomass example. Good biomass example is what we do in our country, right? You have energy waste, waste from various agricultural products, which is converted into biomass, and we use that as an alternative to biofuel, to fossil fuels. Let me give you an example of bad biomass. Bad biomass. Last year, I went to a distillery in Scotland, and at this distillery in Scotland, we went and visited the boiler because it was supplied by our joint venture partners, actually. And when we went and visited the boiler, so I asked them, I said, where do you get your biomass from? Because they were getting these really nice, clean biomass pellets. And he said, oh, we get our biomass pellets from Canada. And I kept thinking, that this makes no sense. So, you harvest a forest in Canada, you turn it into biomass pellets, you ship it across the ocean in a ship that runs on oil, and then this is somehow clean. I have a problem with that. Yeah. So it seems to me, that this is subsidies that take one in a very strange direction. And I think we should make sure that whatever we do is aligned with actually reducing fossil fuel consumption, looking at the whole supply chain.
Thank you, sir. The next question is on energy efficiency. A lot of them have said that we have done well in energy efficiency in India. Many sectors in India are leading the world in terms of energy efficiency. Western world has not done well, particularly Europe and US, he says. How can we make them do better, number one? Number two, how can India lead the world in terms of energy efficiency?
So, so it's not true that the Western world has not done well. The Western world is not one place. If you look at the approach of the US and the approach of Europe have been quite different. Second, within Europe, different countries have very different patterns. And within the US, different states have approached things very differently. So the fuel efficiency standard that I talked about for the US was actually a California standard that was first put through in the 60s in California, so very early on. And then it was adopted nationally after 1973, and adopted nationally and then became a national fuel efficiency standard. And California has typically been at the forefront of climate change mitigation and moves to reduce emissions. Unfortunately, climate change, like everything in the US these days, is a very politicized subject. It shouldn't be, but it is. And it's, that's why the current 45th president pulled the US out of the Paris Accord, and why the 46th president has said that his first act as president will be to put the US back into the Paris Accord. So it's very politicized. But I think we'll see progress in the next 4 years that we haven't in the last 4. If you look at Europe, you have, let's say, a country like Norway, which now has announced that by 2030, it expects, I think it's by 2030, it expects that all new cars sold in Norway will be electric vehicles, which is a very dramatic shift from where it is now. And it already has the highest percentage of electric vehicle sales of any country in the world. If you look at what we're seeing now, different countries have announced that they will emissions have peaked in many countries now, the US, in most of Europe, and many have announced that they will be have net zero carbon emissions by a certain date. So the US and Japan have both recently announced that they will be net carbon neutral by 2050. China's the largest polluter in the world, has announced that it'll be net carbon neutral by 2060. We have to see them get there, but that's what they've announced. And most European countries are going to reach carbon neutrality much before 2050. Some by 2030 and earlier. So I think you see the West actually going ahead with many of these areas, and if you look at Germany's policies on solar power, I always worried about them because I always thought they seem to be Germany is not the country that when I think of Germany, the first thing I don't think of is sun, but they had this extremely ambitious solar power program, which has really had a dramatic effect in terms of renewables as a share of total energy generated in the country. Very far along in its energy conservation and climate change efforts. So I think there's lots to learn from the West, lots to learn from the experience of different European countries, and lots to learn from some states, not the country as a whole maybe, but some states in the US.
Thank you, sir. The next set of questions is around finance. Many of them say, you said about technology being available. He says he has been trying to implement a project for the last 4 years, but every time the project is getting stalled because of finance. What is it that you would like to advise him on?
So it depends on the project and what the payback is. I'll give you. So I think it is an issue, and it isn't an issue. It is an issue for all the longer term payback projects. So if you take solar power, for example, financing is essential, because solar power is what's made solar power viable is actually access to efficient mechanisms for financing and efficient ways in which financing can be combined with the technology to provide this alternative fuel. And if you have paybacks of 5 years and up, only with really good, efficient financing mechanisms do you see those kinds of projects moving ahead. If you have paybacks of, for many of the energy conservation examples I was talking about earlier, they have paybacks of a year, maximum 2 years. If you have a payback of a year and 2 years, financing it's not irrelevant, but it's almost irrelevant. Because why wouldn't you go ahead and do it somehow in the short run, given that it tends to be many small things that do not necessarily involve huge investments.
Thank you, sir. Two questions on what do you think would happen to the trajectory of energy efficiency investments and activities. One, with renewable energy becoming ₹2.30 per unit, will it make the company spend more on putting up renewables rather than working on energy efficiency? Second, will COVID affect the strategies of the companies in terms of their energy efficiency initiatives?
Sorry, what was the second one with regard to COVID?
Will COVID affect the trajectory for energy conservation in industries from a priority or strategy point of view?
So on the first point, I'm not sure it's necessarily that the low cost of renewable energy will affect energy efficiency by industry. I think it's more that it's easier to do something big than to do many small things. And you see, energy efficiency requires doing many small, low investment things. Setting up a power plant is one big thing. So I worry about that more than anything else. making a large investment receives a lot of management attention. It will receive a boardroom presentation and all of that. Energy efficiency involves 100 small things that you have to do that at much lower investment will add up to a greater benefit. But those 100 small things need adequate attention across the organization. And it's much more of a management issue than, if you ask me, a technical issue or even a financial issue. On the COVID question, I worry about COVID in terms of its impact on energy prices. As long as energy prices sustain and energy prices rise, I don't think COVID will have an impact on energy conservation. If COVID leads to a fall in consumption and then a fall in prices that sustains, then that more than anything else is damaging energy conservation efforts.
Thank you. One more question. It's from an engineer who is involved in energy efficiency. There are about 400 young people, particularly energy auditors, energy efficiency engineers, who are listening to this conversation, sir. He says, innovation, a lot of things are happening in IT and other related areas, not much in hardcore energy efficiency. For example, boiler is operating the same as it was about 30 years back. What do you think should be done to promote innovation in these areas?
I think it's a great question. It's one of those, if you look at how do fields like boilers, boilers, the basic construct of a boiler hasn't changed in, when did we go from 2-pass to 3-pass boilers? Oh, I don't know, 40 years back. And that was probably the last significant move forward. Okay, we've since seen, better burners, better combustion technologies, better fluid dynamic modeling so that you can improve air to fuel mixing and so on. I think it's time for another rethink of some of the fundamentals of how we actually run boilers, how efficiently we can make them. Can we shrink the total size down by running boilers on oxygen as opposed to air? Are there opportunities to greatly improve and enhance efficiency through different kinds of materials of chimneys, such that one can have flue gas emissions that are at much lower temperatures and so on? How do we move in the direction of the theoretical efficiency of a boiler? Why is it that at present we're stuck at this 80, 82, 85% range that we should be able to get beyond? So I agree. I think it's a good question. And I think it's the kind of question that, there should be challenges to industry and to manufacturers of boilers like us in terms of saying, well, show that you can make a boiler that operates consistently and on an ongoing basis at 92%, 95%. And never mind if it's not financially viable maybe it's too expensive for people to invest in initially, but show that it's technically possible. And then once it's technically possible, now let's make it financially viable. Because that's how you start. You start by making one, and then maybe when you make 20, you start making it much more feasible from a practical angle.
Thank you, sir. We have some more questions. Probably we are running out of time. As I said, there are about 400 engineers, young people, particularly who are involved in energy and energy efficiency, who are listening to you. What would be your piece of advice to them, Dr. Forbes?
So, first of all, you're in a great field, right? Because you're in a field where the potential is so huge. The number I gave you for the US, the number is not, we don't have a number like that for India, but it's not going to be a different number, right? So if actual energy efficiency in a grand sense is 1/3, right? That only 1/3 of actual energy is converted into useful work. That says you're in the field that should be concerned with that 2/3, right? And how does that 2/3 shrink, right? And what can we do it's the kind of thing that we have to implement and do plant by plant, initiative by initiative, across the board, and see how over time, by things that you all do on a monthly basis, how can we bring about that improvement in energy efficiency that we need? Let me suggest a good target for us. Our goal as a country is to grow our total manufacturing output by around 10% a year over the next decade at least. And that's the best we've achieved in the 2000s, about 10% a year for an extended period of about 8-9 years. And if we're going to grow our total manufacturing output by 10% a year, what is that going to do to our energy consumption in industry? Because typical energy consumption in industry as a percentage of output has been improving by about 2.5% year on year in the country over these last 30 years. Now, if we're going to grow output by 10%, that says we'll grow our energy consumption also by around 7.5%. Is there a way in which we can save so much in terms of our energy consumption that we don't grow our output at all, that our total energy consumed stays where it is now, while our output of industry grows by 10% year on year? It's not easy. It's very challenging. But the first year or the first 2 years are easy because the opportunities are there right now. So let's achieve the first 2 years. And then in the course of the first 2 years, the suggestion I would make to you is that you will yourselves find additional potential. Because as you do particular things in industry, you will find more things that can be done. And those more things can again start turning into new proposals and new opportunities that will exist in our firms. But I think our goal should be that how do we grow our output 10% year on year for 10 years and keep our total energy consumption the same?
Thank you, sir. Thank you. Very, very ambitious target you have given. Thank you very much. We are almost running out of time. May I now request Mr. Ravi to take over and present the concluding remarks, please. Mr. Ravi. Ravi.
I think we may have a connection.
Yeah, thank you. You are muted again, sir. Ravi, you are muted again. Ravi? Yeah.
Can you hear me now?
Yeah, fine, sir. Thank you.
Sorry, I had some problems. I'm getting used to WebEx, so. Sorry about that. Thank you, Dr. Forbes. That was very inspirational, very insightful, and beautifully presented. And I think there's a lot of work to do for us in the space of energy efficiency. And as you rightly said, I mean, it's a great opportunity given the fact that India is $1 trillion manufacturing GDP. So I think there's never been a better moment to really focus on energy efficiency when it comes to India at this point in time. So thanks for that. And I'll move on to the last part of the session. Basically, I just wanted to share with you all that this kind of today what you have said here is kind of a curtain raiser for a week-long energy conservation event that we are launching, Enercon 2020. And move on to the next slide. We have put together a program where we have about 30 plus thought leaders speaking on different teams and different platforms over the next 4-5 days. And this is an afternoon session. We have 6-day virtual session, and we expect about 1,000 plus participants on the Hive platform as well. Next, please. And we've also taken this opportunity to, recognize and, award 2 categories for a poster competition on energy efficiency. The two categories are one for the companies and the other one was for the individuals and companies. And each of these categories have 5 winners. And when I say 5 winners, it's not somebody is 1 or 2, everybody is 1 in that category. The jury, I think we had an eminent panel led by Mr. K.N. Rao, former director and of ACC. But I think for a different approach we have taken here this time is that we had 5 young emerging leaders in energy efficiency who won the award recently in the Energy Efficiency Summit. And these 4 young leaders were the initial first screening jury. And then they finally sat down together with Mr. K.N. Rao and chose these 5 winners. And let me quickly move on to announce the winners. In the best practices in energy efficiency, the winner is Malabar Regional Cooperative Milk Producers Union from Kozhikode. And that's really an exciting thing to get some entries from Kozhikode. Jindal Steel Orissa is a second winner. Tamil Nadu Newsprints and Papers is the third winner. Next, please. Vardhaman Fabrics Budni is the 4th winner. And the 5th winner is National Thermal Power Corporation, Mauda. So these are the 5 winners from a company level. And for the category creating awareness on energy efficiency and energy conservation, we have again 5 winners. Mr. Mahesh Patel, Deputy Manager E&I from JK Lakshmi Cement is the winner. Next, please. Mr. Jai Pratap Singh, Executive, Vardhaman Fabrics for the upcoming energy efficient technologies is the winner. Mr. Shiva Yogimath, Managing Director, Soul Power India is the 3rd winner. And the 4th, Mr. Naveen Kumar Sharma, Plant Head, Udaipur Cement Works. And the last winner, actually 3 of them have set up a team. Vivek Gupta, Senior Maintenance Manager, Mr. Paulo, Mr. Praful Sahani from Indian Oil Corporation, Panipat Refinery. So I would like to thank all the participants who participated in this event, and also my congratulations to the winners. And we are looking forward to an exciting week ahead with 30 plus speakers in the EnerCon 2020. Thank you very much, ladies and gentlemen, and thank you, Dr. Forbes, for that insightful session. It's always, nice to listen to your thoughts, and you clearly have articulated that we are in the right industry, and I'm sure a lot of youngsters listening to us should really go back motivated. And I truly believe we are in the right industry, not because I'm sitting in the industry, which is energy efficiency, but I think we are in the cusp of transformation, in my view, where we can make a big difference to the sustainable development goals through the energy efficiency and climate change. And also we make a lot of sense for people and planet. So on that high note, I would like to thank everybody for joining us in this Energy Efficiency Leadership Series session. And I really look forward to welcoming you all tomorrow for the EnerCon 2020. Thank you very much, and we are signing off from here.
Thank you, Ravi. Thank you. Thank you, Dr.
Thank you. Bye-bye. Thank you. Thank you.